Hello everyone, welcome to CodeChef. Myself Jwala Chaurasia and today we are going to solve the problem which came into Starters 198. The name of the problem is currency exchange and the problem code is CUREX. The difficulty rating of the problem is cakewalk and the prerequisite is adopt. Let's start with reading the problem statement over here. So guys, problem says Chef currently has A of 1 gold coins and B of 1 silver coins with him. He can perform the following three types of transformations. Pay one gold coin and receive five silver coins. This can only be done if he has at least one gold coin. Pay five silver coins and receive one gold coin. This can only be done if he has at least five silver coins. Discard one gold coin and one silver coin. This can only be done if he has at least one gold coin and at least one silver coin. Is it possible using these transformation for chef to end up with exactly A2 gold coins and B2 silver coins? Input format. The first line of input will contain a single integer t denoting the number of test cases. The first and only line of each test case contains four space separate integers a1, b1, a2, and b2. The initial and the target number of goals of silver coins we have to reach. Output format. For each test case, output the answer on a single line. Yes, if it is possible to reach a2 gold and b2 silver coins and no otherwise. Constraint for t lies from 1 to 1000. For a1, b1, a2, and b2 lies from 0 to 1000. So guys, now let's understand the sample test case in the question work is over here. So guys, this question is pretty much straightforward to understand. It says that chef currently has A1 gold coins and B1 silver coins with him, and he can perform the following three types of operation. That is, pay one gold coin and receive five silver coins. This can only be done if he has at least one gold coin. Pay five silver coins and receive one gold coin. This can only be done if he has at least five silver coins. Discard one gold coin and one silver coin. This can only be done if he has at least one gold and one silver coin, right? Of course. So is it possible to using these following transformation to convert these A1 B1 to A2 B2 or not? Okay, by performing these operations basically. Now let's take the first test case. We have got A1 B1 and A2 and B2. Okay, so 2 1 2 1. So here you can see A1 is already equal to A2 and B1 is equal to B2. So they have already same. So output for this test case is simply yes. Okay. Now let's go for another test case, guys. So we will take this second one. So which is 2 1 1 5. Basically A1, B1, A2, and B2. Okay. So it can be shown that it's impossible to obtain one gold coin. Yeah, and five silver coin, starting with two gold and one silver coin, of course. Over here, there is no possibility by following this uh, transformation we can achieve this. Okay, so output for the test case simply no. Now let's take another test case, guys. So the another test case is A1, B1, A2, B2, which is 3205. Okay. So we start with three gold coins and two silver coins. So let's say first discard one gold coin and one silver coin. So it will become how much? Two and one. Okay. So next pay one gold coin, which will transform to five silver coins. So it will become one, one plus five, which will become six. Okay. So now discard one gold coin and one silver coin, then it will become zero and five. So yeah, it is possible by these of the transformation we can achieve this transformation. Yeah. So output for the test case simply yes. So guys, I think the test cases are pretty much clear. Now let's move toward the simple solution. So observe that we aren't able to freely transform between gold and silver coins at a rate of 1 is to 5, right? So we can think of each gold coin as having a value of 5 silver coins. The initial value of coins with us is 5, A1 plus B1 silver coins, while we want to end up with a value of 5, A2 plus B2 silver coins. The only option we have that actually change the value is the option to discard one gold coin and one silver coin. In particular, this means we can only reduce the value of a coins and never increase it. So if 5 times of A1 plus B1 is lesser than 5 times of A2 plus B2, it's definitely impossible to end up with A2 B2 coins, right? So now let's look at how exactly the value reduces. So we discard one gold coin and one silver coin. The gold coin is worth 5 silver coins, so we have really discarded the equivalent of 6 silver coins from the overall value, right? Since each time we discard a value of 6, the only values we can reach at all are those of the form 5 times of a1 plus b1 minus 6 times of k for some integer k greater than equal to 0. So now 5 times of a2 plus b2 must be of this form, which is impossible if 5 times of a1 plus b1 minus 5 times of a2 plus b2 is divisible by 6. If it is not, again we know it's impossible to end up with a2 b2. We now have a situation where two conditions are true. That is, first one, 5 times of a1 plus b1 is greater than equal to 5 times of a2 plus b2, and the second one, 5 times of a1 plus b1 is 5 times of a2 plus b2 is divisible by 6. Okay, so from here we can say that this is in fact always possible to transform a1 comma b1 into a2 comma b2 under these conditions. Let's see the condition. That is, first transform all gold coins to silver coins. There are now 0 gold coins and 5 times of a1 plus b1 silver coins, right? Next, while the value of our coin is larger than 5 times of a2 plus b2, do the following. Transform 5 silver coins to 1 gold coin, then discard 1 silver and 1 gold coin. This reduces the value by exactly 6, since we know 5 times of a1 plus b1 minus 5 times of a2 plus b2 is divisible by 6. Repeating the above process will eventually land us in a state where we have exactly 5 times of a2 plus b2 silver coins and 0 gold coins. Now transform 5 times of a2 silver coins to gold, after which we will have a2 gold and b2 silver coins as needed. To summarize, the answer is yes if 5 times of a1 plus b1 is greater than 5 times of a2 plus b2, and 5 times of a1 plus b1 minus 5 times of a2 plus b2 is divisible by 6 and no otherwise. So guys, I think the solution is pretty much clear. Now let's move toward the simple solution, C++ code for this question. So guys, this is the simple C++ code for the question. Yeah. I took the input for all the test cases as well as A1, B1 and A2, B2. Over here, I initialize C1 equal to 5 times of A1 plus B1 and C2 is equal to 5 times of A2 plus B2. Okay. So if C1 is greater than equal to C2 and C1 minus C2 modulo 6 equal to 0, we will print yes. In all the other cases, I will simply print no. And as you can see that guys, I have got my C++ code right now. Let's move toward the Python code. So guys, this is my simple Python code. I took the input for all the test cases as well as A1, B1, A2, B2. Over here, I initialize C1, C2 equals to 5 times of A1 plus B1 and C2 equal to 5 times of A2 plus B2. If C1 is greater than equal to C2 and C1 minus C2 modulo 6 is equal to 0, we will print yes. In all the other cases, I will print no. And as you can see that guys, I have got my Python code right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our video.